Good morning, students. Unit 11, Integral Calculus. We have studied the Unit 10, Differential Calculus. The Integral Calculus will say as antiderivative. So, this also was one important unit for the higher studies. As a differential calculus, how we are going to give the importance, the same importance we need to give for integral calculus also. There are some formulas we need to derive. The first formula, nothing but x power n. X power n into dx is nothing but x power of n plus 1 divided by n plus 1. We will add one constant called c. X power n into dx is nothing but x power n plus 1 divided by n plus 1 plus c. This is the integration symbol. We are integrating x with respect to dx. X power of n plus 1 divided by n plus 1 plus c. Okay. If we are going to study the second formula, integration of dx is nothing but x plus c. Integration of dx is nothing but x plus c. Suppose the same phi into dx. Integration of phi in dx, we can put phi constant outside. Integration of dx is nothing but phi is a constant, right, as it is. Integration of dx is nothing but x. We need to add one constant called c. So phi into dx is nothing but phi x. The same if we are going to differentiate d divided by dx, x power n is nothing but nx power of n minus 1. This is a differentiate. That is integration of dx. That is, we can keep it as 1 also, no problem. So we need to study the formula for differentiate and integrate properly. Otherwise, we can't able to derive this sum properly. So this is the integration symbol. Integration of phi into dx is nothing but we can put phi outside. Integration of dx is nothing but x. We need to add one constant called c, nothing but phi x plus c. So fourth formula, integration of 1 by x into dx is nothing but log x plus c. You know, differentiate of log x. D by dx, differentiate of log x is nothing but 1 by x. Differentiate of log x is nothing but 1 by x. Here differentiate of log 1 by m. Here integration of 1 by x into dx is nothing but log x plus c. So the fifth formula is nothing but sin x into dx. Nothing but minus cos x plus c. Sin x into dx is nothing but minus cos x plus c. Integration of cos x into dx is nothing but sin x plus c. Seventh formula, integration of, after cos x we are going to see tan x. Integration of tan x into dx is nothing but we can choose two formulas. One is minus log cos x plus c or log of modulus of secant x plus c. Sometimes we don't need to put modulus also, we will put bracket, no problem. Listen carefully. Sometimes we will don't put modulus, we will put just a bracket, so no problem here. Seventh. Next, eighth formula, integration of cot x into dx. Nothing but log modulus of sin x plus c. Otherwise, we can write another formula also, minus of log cosecant x plus c. Both are same. We can use any one formula. Integration of cot x something, but we can use log sin x. Once again saying, you don't need to put modulus also. Sometimes we'll put bracket, log of sin x. We'll put bracket also. This is the eighth formula. Next, if we're going to see the ninth formula, integration of secant x into dx is nothing but log modulus of secant x plus tan x plus c. Okay, this is the ninth formula. Next, tenth formula, integration of cosecant x into dx is equal to log of modulus of cosecant x minus cot x plus c. This is 10th formula. Next, 11th formula, integration of a power x into dx is equal to a power x divided by log a plus c. A power x, this is nothing but constant, 5 power x, 6 power x, 10 power x. You want to write a power x divided by log a plus c. Next, we are going to see another important formula, e power x into dx is nothing but e power x plus c. Integration of e power x is nothing but e power x, the straight formula. Integration of e power x is nothing but e power x. Next, formula number 13. This the forthcoming formulas are very important. So 1 divided by x square plus a square into dx. 1 divided by x square plus a square into dx. Otherwise we can write 1 into dx is dx. No, dx divided by x square plus a square. We can write whatever it means. 1 divided by a tan inverse of x by a plus c. This is the next formula. Next formula number 14. The same formula 1 divided by x square plus 1. Because a square is nothing but 1, no, into dx. You can write otherwise dx divided by x square plus 1 is equal to, what is a here? A is nothing but 1. So we don't need to write this one. You can write straightly as tan inverse of x plus c plus c. Tan inverse of x plus c. Next formula number 15. Integration of 1 divided by a square minus x square. A square minus x square into dx is equal to 1 by 2a log modulus of a plus x divided by a minus x plus c. Whenever log comes, we are putting modulus. Why we are putting modulus now? Because log of negative is impossible. Log of minus 5 is impossible, but log of 5 is possible. If you are going to see in logarithm table, log of minus 5 is not, there is no value for log of minus 5. That is log 5. Okay, only. So log of minus is not impossible one. It's not a possible one. So only, even though if you're going to get minus, this minus will make us plus. So only we are going to use modulus. Okay. Next is formula number 16. 1 divided by x square minus a square into dx is equal to 1 by 2a log of x minus a divided by x plus a plus c. Next, 17th formula, integration of dx divided by square root of a square minus x square into dx is equal to sine inverse of x by a plus c. 18th formula, integration of dx divided by square root of x square plus a square into dx is equal to log of modulus of x plus square root of x square by a square plus c. 19th formula. This, see, we going, these are division, this is also division, this is square root division. Next, if we going to write the formulas in numerator formulas. Formula number 19. Integration of square root of a square minus x square into dx is equal to 1 by 2. In spite of writing 1 by 2, we will write x by 2. X by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a plus c. Formula number 20. Integration of square root of x square plus a square into dx is equal to x by 2 square root of x square plus a square by 2 log of modulus of x plus square root of x square plus a square plus c. Formula number 21. Integration of square root of x square minus a square into dx is equal to x by 2 square root of x square minus a square by 2 log modulus of x plus square root of x square minus a square plus c. The last formula we will say, otherwise we can write some more formulas also. 1 divided by x into square root of x square minus a square is equal to 1 by a secant inverse of x by a plus c. Formula number 23. So f dash of x divided by f of x into dx, we can write log of f of x plus c. You can put modulus log of f of x plus c, nothing but if I going to differentiate f of x, this is a denominator. If I going to differentiate denominator, f of x differentiate is f dash of x. If I going to get a numerator, we can say log of denominator, nothing but log of f of x, log of f of x. So another formula 24, integration of f of x. For example, we can see you will take f of x, f dash of x divided by square root of f of x into dx. We can write 2 into square root of f of x plus c, nothing but this is in the square root, no, square root of f of x differentiate is f dash of x in the square root. then we can write 2 into square root of f of x plus c. The another formula we can write, this formula is one of the important formula only, formula number 25. The integration of e power ax sin bx into dx is equal to e power ax divided by a square plus b square a sin bx minus b cos bx plus c. Some form number 26, e power ax cos bx into dx is equal to e power ax divided by a square plus b square, open the bracket, a cos bx minus b sin bx plus c. So there are two more formulas. One is Bernoulli's formula, next one is integration by parts. While I am using, I will teach you. These are the formulas you need to memorize. So I not given any example for any formulas. I have directly derived I written all the formulas. So first, before you involving inside the sum or before deriving the sum, better memorize this formula. If you are going to memorize this formula, then you can do the sum very easily. The main and important thing I need to say here is, if once you know the differentiate properly only, you can able to do integration. If you doesn't know the differentiate, you can't able to understand the integrate. So differentiate is very important thing to know to do integration. If you doesn't know the differentiate, you will doesn't know integration, you can't able to understand integration also. Somewhat, if you know somewhat, sir, I know the differentiate, sir, I will can't able to read integration, sir, comes. If you going to read integration, there will be some collapse, you will occur some collapse here. There will be some collapse. You will be confused after reading the differentiate. Once you enter the integrate, it will be very confusing for you. Openly say, very confused for you. What formulas will be very confused. The method will be very confused. So read the differentiate properly. You want to learn the differentiate properly, then only you can able to derive integrate properly, because sometimes the differentiate and integrate will be collapsed for you. So only in exercise 11.1 I am going to teach you the differentiate and integrate both simultaneously, so that you will understand very easily. I will try to teach you each and every sum in differentiate also, so no problem. But my concern on you is read differentiate properly, then you will comes to know how beauty of integration is. Okay, so read integration properly. Now I move towards exercise 11.1. In exercise 11.1, I am going to, they were told to derive only integration only, but I am going to derive both differentiate and integrate for each and every sum, so that it will be very helpful for you to find the difference between the differentiate and integration. Thank you.